Okay, for this problem we have two random variables x and y that are both normal with mean 0 and variance sigma squared, standard deviation sigma. They are independent and they represent the x and y coordinates of shots at a target, and r equals square root of x squared plus y squared is the distance of that shot from the origin. Find the probability that r is less than or equal to sigma over 2. All right, to do this one, I'm going to use a couple of tricks so that I don't have to reinvent the wheel, because a few of the things that I need to do this problem we've actually done in class already. So first off, let z1 be equal to x1 divided by sigma, and let z2 be equal to, not x1, x over sigma, and let y be, z2 be y over sigma. Now, why do I do this? Well, if I take this random variable, subtract the mean, minus 0, divide by the standard deviation, that is now standard normal. Likewise with this one, if I take y minus its mean and divide by its standard deviation, this will also be standard normal. So z1 and z2 are standard normal. And we showed in class, and actually in review problem 3.1, that if that happens, then z1 squared and z2 squared actually follow a gamma distribution with parameters 1/2 and 1/2. Okay, so that's a nice little feature that I'll use in this problem. The probability that r is less than or equal to sigma over 2, let me rewrite that as the probability that r squared is less than or equal to sigma squared over 4. Now r squared is x squared plus y squared, and that has to be less than or equal to sigma squared over 4. And by definition here, x is equal to sigma squared times z1 squared, and y squared is sigma squared times z2 squared. So that has to be less than or equal to sigma squared over 4. And so very nicely, the sigmas cancel, and so I get the probability that z1 squared plus z2 squared is less than or equal to 1/4. Now let me just call that t. That's the sum of those two random variables, z1 squared plus z2 squared. Let me just call that t. Now this is actually another theorem that we proved in class. z1 and z2 are independent because x and y are independent. So that means that z1 squared plus z2 squared also will follow a gamma distribution. And it will follow a gamma distribution with parameter 2 times 1/2, 1/2, where I take this number and add it to itself. So that's gamma with parameter 1, 1/2. Now this gets simplified even further, because the gamma distribution, when I have an integer, this is waiting for the first arrival when lambda is equal to 1/2. Waiting for the first arrival is the same thing as the exponential distribution with parameter 1/2. So z1 squared plus z2 squared, my parameter t here, has an exponential distribution with parameter 1/2. So this is equal to the integral from 0 to 1/4 of 1/2 times e to the minus x over 2 dx. That is the PDF for an exponential distribution with parameter 1/2. And I want the probability that t is between 0 and 1/4. So doing the integral, we get negative e to the minus x over 2, evaluated from 1/4 to 0. And plugging in, we get negative e to the negative 1/8 minus negative e to the 0. So the practical effect is this is 1 minus e to the negative 1/8 power. And that's the probability that the shot is within sigma over 2 of the target.